Hello students, in this lecture I will be discussing about the topic of computer networking. How networking of computer works, how data is shared amongst the connected computers using networking system. A computer network or a data network is a technology which primarily used between two devices to communicate and transfer data with each other. Moreover, it is also used to communicate with other devices like printer and fax. In computer networks, networked computing devices pass data to each other along data connections. The connections between two devices or nodes are done by a cable media or wireless media. The best known example of network till date is the internet. Network computer devices that originate, route and terminate the data are called network nodes. Nodes can include hosts such as personal computers, phones, servers as well as networking hardware. Two such devices are said to be networked together when one device is able to exchange information with the other device, whether or not they have a direct connection to each other. Computer networks support applications such as access to the World Wide Web, shared use of application and storage servers, printers, fax machines and use of email and instant messaging applications. Computer networks differ in the physical media used to transmit their signals, the communications protocol to organize network traffic, the network size, network topology and organizational intent. Now, let us know how evolution of networking took place in history of computer networking. In the late 1950s, early networks of communicating computers included the military radar system known as SAGE, that is Semi-Automatic Ground Environment. Then in 1960, the commercial airline reservation system Semi-Automatic Business Research Environment or known as SABRE, SABRE went online with two connected mainframe computers. In 1962, JCR Licklider developed a working group he called the Intergalactic Computer Network, a precursor to the ARPANET at the Advanced Research Project Agency, that is ARPA, ARPA. And in 1964, researchers at Dartmouth developed the Dartmouth time sharing system for distributed users of large computer systems. The same year, at Massachusetts Institute of Technology, that is MIT, a research group supported by General Electric and Bell Labs used a computer to route and manage telephone connection. Throughout the 1960s, Leonard Kleinrock, Paul Baran and Donald Davis independently developed network systems that used packets to transfer information between computers over a network. In the year 1965, Thomas Merrill and Lawrence G. Roberts created the first wide area network or WAN. This was an immediate precursor to the ARPANET, of which Roberts became program manager. And in this year, the first widely used telephone switch that implemented true computer control was introduced by Western Electric. In 1969, the University of California at Los Angeles, the Stanford Research Institute, the University of California at Santa Barbara and the University of Utah were connected as the beginning of the ARPANET networks using 50 kilobits per second circuits. Then in late 1972, commercial services using X.25 were deployed and later used as an underlying infrastructure for expanding TCP/IP networks. In 1973, Robert Metcalfe wrote a formal memo at Xerox PARC describing Ethernet, a networking system that was based on Aloha Network. developed in 1960s by Norman Abramson and colleagues at the University of Hawaii. In July 1976, Robert Metcalfe and David Boggs published their paper titled as Ethernet Distributed Packet Switching for Local Computer Networks, and collaborated on several patents received in 1977 and 1978. In 1979, Robert Metcalfe pursued making Ethernet an open standard. In 1976, John Murphy of Data Point Corporation created ARCnet, ARCNET, a token passing network first used to share storage devices. In 1995, the transmission speed capacity for Ethernet was increased from 10 megabits per second to 100 megabits per second. By 1998, Ethernet supported transmission speeds up to a gigabit. The ability of Ethernet to scale easily, such as quickly adapting to support new fiber optic cable speeds, is a contributing factor to its continued use today. So, this is how the evolution of computer networking took place and still continued today. Facilitate communication. The primary purpose of computer networking is to facilitate communication. A network allows a user to instantly connect with another user or network and send and receive data. It allows remote user to connect with one another via video conferencing, virtual meetings, and digital emails. Computer networks provide access to online libraries, journals, electronic newspapers, chat rooms, social networking websites, and email clients, and most importantly, the World Wide Web. Users can benefit from making online bookings for theaters, restaurants, hotels, trains, and airplanes. They can shop and carry out banking transactions from the comfort of their homes. Computer networks allow users to access interactive entertainment channels such as video on demand, interactive films, interactive and live television, multi-person real-time games, and virtual reality models. Resource sharing. Computer networks allow users to share files and resources. They are popularly used in organizations to cut costs and streamline resource sharing. A single printer attached to a small local area network can effectively service the printing requests of all computer users on the same network. User can similarly share other network hardware devices such as modems, fax machines, hard drives, and removable storage devices. Networks allow users to share software applications, programs, and files. They can share documents such as invoices, spreadsheets, and memos, word processing softwares, videos, photographs, audio files, project tracking software, and other similar programs. Users can also access, retrieve, and save data on the hard drive of the main network server. Centralized support and administration. Computer networking centralizes support, administration, and network support tasks. Technical personnel manages all the nodes of the network, provide assistance, and troubleshoot network hardware and software errors. Network administrators ensure data integrity and device systems to maintain the reliability of information through the network. They are responsible for providing high-end antivirus, anti-spyware, and firewall softwares to the network users. Unlike a standalone system, a networked computer is fully managed and administered by a centralized server, which accepts all user requests and services them as required. Today, Computer networks are the core of modern communication. All modern aspects of the public switch telephone network, that is PSTN, are computer controlled. Telephony increasingly runs over the internet protocol, although not necessarily the public internet. The scope of communication has increased significantly in the past decade. This boom in communications would not have been possible without the progressively advancing computer network. Computer networks and the technologies that make communication between networked computers possible continue to drive computer hardware, software and peripheral industries. The expansion of related industries is mirrored by growth in the numbers and type of people using networks, from the researchers to the home users. Computer networking may be considered a branch of electrical engineering, telecommunications, computer sciences, information technology or computer engineering. Since it relies upon the theoretical and practical application of the related disciplines, a computer network has the following properties. 1. Facilitates interpersonal communications. People can communicate efficiently and easily via email, instant messaging, chat rooms, telephone, video telephone calls and video conferencing. 2. Allows sharing of files, data and other types of information. Authorized users may access information stored on the other computers on the network. Providing access to information on shared storage devices is an important feature of many networks. 3. Allows sharing of network and computing resources. Users may access and use resources provided by devices on the network, such as printing a document on a shared network printer. Uses computing resources across a network to accomplish tasks. 3. Interference with other technologies. Interference with other technologies strongly disturbs certain forms of radio communication, for example, amateur radio. It may also interfere with access technologies. 4. Difficult to set up. A complex computer network may be difficult to set up. It may be costly to set up an effective computer network in a large organization. Now we will understand what all basic equipments required for networking of 2 or more computers. For a basic network connection, few items are needed: 2 or more hosts or computers or network capable devices, media for connection as cable or wireless, network devices to connect more than 2 devices or not directly connecting devices like routers. Network devices can be connected directly, which is called peer-to-peer connection, or can be connected in a group of devices. There are certain protocols and rules to connect and process, which is mandatory to achieve best result. To transfer data and information, we need a set of rules which can be understood by all network devices. These rules are called protocols, and to process the information and making it transferable on network, a process is used called OSI model. Next, we will study the 3 basic networking types. 1. LAN or local area network is a set of group of computers or devices. A networked office building, school or home usually contains a single local area network, though sometimes one building will contain a few small LANs, perhaps one per room, and occasionally a LAN or local area network will span a group of nearby buildings. WAN or wide area network. Wide area network is a network where a PC or group of PC connects to other network or internet. Residences typically employ one LAN and connect to the internet WAN via an internet service provider, that is ISP, using a broadband connection. The ISP provides a WAN IP address to the modem, and all the computers on the home network use LAN, so called private or IP addresses. Home network use LAN IP addresses. All computers on the home LAN can communicate directly with each other, but must go through a central gateway, typically a broadband router, to reach the ISP, that is Internet Service Provider. MAN or Metropolitan Area Network. MAN is a computer network in which two or more computers or communicating devices or networks which are geographically separated but in same metropolitan city and are connected to each other, said to be connected on Metropolitan Area Network. Metropolitan limits are determined by local municipal corporations. The larger the city, the bigger the MAN. The smaller the metro city, smaller the MAN. The OSI or Open System Interconnection model defines a networking framework to implement protocols in 7 layers. Control is passed from one layer to the next, starting at the application layer in one station and proceeding to the bottom layer over the channel to the next station and back up the hierarchy. The OSI model does not do any functions in the networking process. It is a conceptual framework, so we can better understand complex interactions that are happening. The OSI model takes the task of internetworking and divides that up into what is referred to as a vertical stack that consists of the following layers. First is physical layer. This layer conveys the bit stream, electrical impulses, light or radio signals through the network at the electrical and mechanical level. It provides the hardware means of sending and receiving data on a carrier, including defining cables, cards and physical aspects. Fast Ethernet, RS-232 and ATM are protocols with physical layer components. 2 is data link. At this layer, data packets are encoded and decoded into bits. It furnishes transmission protocol knowledge and management and handles error in the physical layer, flow control and frame synchronization. The data link layer is divided into 2 sub layers, the media access control, that is MAC layer, and the logical link control, that is LLC layer. The MAC sublayer controls how a computer on the network gains access to the data and permission to transmit it. The LLC layer controls frame synchronization, flow control and error checking. Layer 2 data link examples include PPP, FDDI, ATM, IEEE 802.5/802.2, IEEE 802.3/802.2, HDLC and frame relay. Then comes the third layer, network. This layer provides switching and routing technologies, creating logical paths known as virtual circuits for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as addressing, internet working, error handling, congestions control and packet sequencing. Layer 3 network examples include AppleTalk, DDP, IP and IPX. Fourth is transport layer. This layer provides transparent transfer of data between the systems or hosts and is responsible for end-to-end error recovery and flow control. It ensures complete data transfer. Layer 4 transport examples include SPX, TCP and UDP. Then comes the fifth session layer. This layer establishes, manages and terminates connections between applications. The session layer sets up, coordinates and terminates conversations, exchanges and dialogues between the applications at each end. It deals with sessions and connection coordination. Layer 5 session examples include NFS, NetBIOS names, RPC and SQL. After session layer, there is a presentation layer. This layer provides independence from differences in data representation. For example, encryption by translating from application to network format and vice versa. The presentation layer works to transform data into the form that the application layer can accept. This layer formats and encrypts data to be sent across a network, providing freedom from compatibility problems. It is sometimes called the syntax layer. Layer 6 presentation examples include encryption, ASCII or ASCII, EBCDIC, TIFF, GIF, PICT, MPEG, JPEG and MIDI. Last layer is application layer. This layer supports application and end user processes. Communication partners are identified, quality of service is identified, user authentication and privacy are considered, and any constraint on data syntax are identified. Everything at this layer is application specific. This layer provides application services for file transfer, email and other network software services. Telnet and FTP, that is file transfer protocol, are applications that exist entirely in the application level. Layer 7 application examples include www browsers, NFS, SNMP, Telnet, HTTP and FTP. A communications protocol is a set of rules for exchanging information over network links. In a protocol stack, each protocol leverages the services of the protocol below it. An important example of a protocol stack is HTTP running over TCP, over IP, over IEEE 802.11. TCP and IP are members of the Internet Protocol Suite. IEEE 802.11 is a member of the Ethernet Protocol Suite. This stack is used between the wireless router and the home user's personal computer when the user is surfing the web. Whilst the use of protocol layering is today ubiquitous across the field of computer networking, it has been historically criticized by many researchers for two principal reasons. Firstly, abstracting the protocol stack in this way may cause a higher layer to duplicate functionality of a lower layer. A prime example being error recovery on both a per link basis and an end-to-end basis. Secondly, it is common that protocol implementation at one layer may require data state or addressing information that is only present at another layer, thus defeating the point of separating the layer in the first place. For example, TCP uses the ECN field in the IPv4 header as an indication of congestion. IP is a network layer protocol, whereas TCP is transport layer protocol. Communication protocols have various characteristics. They may be connection oriented or connectionless. They may use circuit mode or packet switching, and they may use hierarchical addressing or flat dressing. Users and network administrators typically have different views of their networks. Users can share printers and some servers from a work group, which usually means they are in the same geographic location and are on the same LAN, whereas a network administrator is responsible to keep that network up and running. A community of interest has less of a connection of being in a local area and should be thought of as a set of arbitrarily located users who share a set of servers and possibly also communicate via peer-to-peer technologies. Network administrators can see networks from both physical and logical perspectives. The physical perspectives involves geographic location, physical cabling and the network elements, for example, routers, bridges and application layer gateways that interconnect the physical media. So, today we have studied about the computer networking, all about how does it emerged and what all benefits we have using computer networking. Thank you.